All right, we're moving on into section 2 of module 4. And the title of this section is Constant Rates of Change. And our essential question here is, how do I identify and write proportional relationships? And hint, it's tied to having a constant rate of change. So I'll let you get your essential question on there. And we do have 4 vocabulary phrases or terms here that we need to identify today. If you used your glossary in the back of the book, which is not a bad thing, but if you picked up the book definition for what rate of change is, it starts getting into things with the dependent variable, the independent variable, and things that we might not be as familiar with. And in your notes, I like to make things a little more concise because it's your notes. We don't have to have a formal sentence for it. So here's what I'm going to have you write here. A rate of change is a rate. And remember what that means. A rate is a ratio. In other words, we're comparing two numbers, and we often write it as a fraction. And typically they have different units, like miles per hour or dollars per ounce, like you did in the shopping activity the other day. So when we talk about a rate of change, we're talking about a rate. And right next door here, I want you to write a fraction, okay? And what I'm going to have you do is write y over x. Now, when we think of graphing or when we're thinking of a table, typically in your table, you would have the x values either on top and the y values on the bottom, or if you are making it vertically, you usually have your input or your x values on the left and your y values on the right. When we make this and try to find the rate of change, we're always going to put the y value over the x. So we kind of have to solidify that in your head, okay? In fact, let's make a little table here, okay? Your textbook often gives it to you this way, like this. So let's say for whatever reason, maybe this is, hours and money or something like that. And let's say that my x value was 3 and my y value was 4.5 or 4 5/10. And then for 4, let's say it's 6. And for 5, let's say it is 7.5. And what you would do to calculate the rate is you would have to take the y value divided by the x value. So you would take 4.5 divided by 3, 6 divided by 4, 7.5 divided by 5. So see, my table looks this way, but really, when we're talking rate of change, we take the y value divided by the x value. It just is. Mainly because the x value here is considered the independent variable. So I'm just going to have you write that here. Independent. And the y value is dependent. Because typically, let's say this was something like hours and this is money or something like that. Typically, time is your independent variable, your input, and then you calculate the other thing based on that. If I were graphing, draw this little guy in here too. I knew I should have given you more room to write here. But x is the horizontal axis, y is the vertical axis. So take y divided by x when you calculate these, okay? That's what we call the rate of change. Now, the next one, proportional relationship. A proportional relationship is defined as a relationship or a set of ordered pairs or a table like this where all rates of change are equal. Rates of change are equal to each other. They're equivalent. And if you look at that example that I just gave you, where you have 4.5 over 3. And if you grab your calculator, ta-da, and divide that, you'll get a number value. That would be the unit rate, right, like you did yesterday, you'd get a value you could write over 1. If I told you to take 6 divided by 4, if I told you to take 7.5 divided by 5, and you simplified all of those values, you get exactly 1.5. And hot diggity, they're all the same. So you could say, hey, this relationship illustrated in that table is proportional. Cool. Now, what is a proportion then? A proportion is some kind of equation where you have two ratios that are equal to each other. So for example, something like, 3/6 and 1/2. I know that in simplest form, this is the equivalent of this one. And if I say they're equal, boom, that's a proportion. Okay? The constant of proportionality, go back up here to this example where I had in that table. Every time we divided these, that 4.5 divided by 3, the 6 divided by 4, the 7.5 divided by 5, that is the constant rate of change, or that number value. So instead of saying constant, let me say it's a number, and it's where all the rates of change are equal. Or maybe we should say the unit rate, because that's really what you do when you divide and simplify all those. Okay, so it is a number. It is the unit rate in a proportional relationship where they're all the same. So for example, on this one, you got 1.5 for 4.5 divided by 3. On 6/4, you got 1.5. You got 7.5 divided by 5 is 1.5. They're all the same. When we say constant, that's what we mean. They are all the same. All right, now let's take a look at one of these examples. Let's say we've got the, big old tortoise. The tortoise moves slowly, but at a steady pace. And someone took the time to measure it and said in 3 seconds, that tortoise traveled 10.5 inches. So that 3 seconds, they've kind of illustrated this by breaking it out in a visual block of 1 second, 1 second, 1 second. It's asking you, use this bar diagram to determine how many inches that tortoise moved in 1 second. In other words, 10.5 inches for 3 seconds, that's a rate, different units. I'm comparing two numbers with different units. When you divide it so that you get 1 second, you get, on your calculator, you'd get exactly 3.5. What operation did we use? We used division, and it turns out we figured out his unit rate is 3.5 inches in 1 second. I'm going to put that right here. We know 3 seconds was 10.5 inches, and if that's a constant speed, if he's going at that rate, add another 3.5 here. Add 3.5, I get 10.5. Add another 14, 17.5. Okay, now I may have jumped ahead a little bit, but it says for each column of this table, so these two numbers, these two numbers, these two, these two, these two, find the distance and time and then write each fraction as a decimal. Put the distance in the numerator. That's because we're considering distance the dependent variable, or y. Time almost always is x, or the independent variable. So we're not going to write 1 over 3.5. We're going to write 3.5 or 3.5 over 1. And when you divide those two, you simply get 3.5. 7 over 2. 7 divided by 2 is 3 5/10. 10 5/10 divided by 3. 3 5/10. Ooh, see what's happening? 14 divided by 4, 3 5/10. 17.5 divided by 5, 3 5/10 again. Aha! When they are constant like that, that's a good thing to notice. Go ahead and flip to the next part. And it says, what do you notice about the decimal forms? They are all the same, or we can say they are equal. In other words, they were 3 5/10. How do you think the distance a tortoise travels is related to the time? They are proportional. It's a constant rate of change. So we would say this relationship is proportional because it has a constant rate of change. Suppose the tortoise travels for 12 seconds. Woohoo! Going on a marathon. Explain how you could find the distance the tortoise travels. Well, if we know the constant rate or speed is 3.5 inches in 1 second, and we want to figure out how far is that sweet tortoise traveling in 12 seconds, multiply by 12, multiply by 12. Explain how you would find it. We would multiply by 12. And when you do that, okay, so I'm looking for this value, the inches, take 3 5/10 multiplied by 12, and I believe you get 42 inches. Okay, so how would you describe the rate of speed at which this tortoise travels? I would describe it, 1, number-wise, it's 3 5/10 inches per 1 second, and it is a constant rate. Constant rate. There we go. So this is what we're focusing on today. You need to check every single time. If you get this same value, it indeed is going to be a constant rate of change, which makes our relationship proportional. Oh, look at the puppies. Callie earns money by dog sitting. Based on this table that you see here, is this relationship between the amount Callie earns and the number of days a proportional one? Remember what I've said is that that top row is your input. That's your independent variable. That's X. The bottom row is what is calculated or is dependent upon that independent variable. So money is my Y value. What we need to do is figure out this rate of change for each one of these. So this will be 16 over 1. This will be 32 divided by 2, 48 divided by 3, and so on. Okay, now when I come down here, 16, 16, 16, can you keep it going? 16, 16, woo! They are all the same. And when that happens, we can say that this is our constant rate of change. And is this proportional? Yes, it is proportional. Boom. Let's look at another one. Here's a table. It shows the distance that Allison drove on one day of her vacation. Now, I was trying to think of something that would be about 300 miles away from us. So here we are at our middle school. Driving up I-35 and then taking 33 to 53, going through the beautiful town of Virginia, and getting all the way up to the border to International Falls. That's almost exactly 300 miles. Psst, it's a little over, okay? So here's how Allison traveled. And they're asking you, is the relationship between distance and time a proportional relationship? Please put X on that top row for time. Put Y for the distance, because we're really calculating her miles per hour, the unit rate, which is Y over X. I'll put the labels in there too, just to help you out. Miles per hour, 65 over 1, 120 over 2, 195 over 3. 220 miles has elapsed at 4, which, by the way, is pretty much getting all the way to Virginia. And 300 over 5. Alrighty here. Simplify these and see what happens. That first hour, she's averaging 65 miles per 1 hour. 120 over 2. Bzzzt. In fact, I can get my no button out here and say, no! Sorry, because this simplifies to be 60 over 1 for that rate elapsed over those 2 hours. So maybe she got into traffic, maybe she had to quick make a stop, pick up some gum, go through the drive-thru and get a giant Dr. Pepper to get her through this drive. Who knows? But here's what's happening. It says, is the relationship between distance and time a proportional one? No. In fact, you can stop right here when you get a difference. 195 over 3, that does end up being 65 over 1 again. But here you get 55 over 1, and then we're back at 60. So our rates are fluctuating throughout the table, which means I'm not going to get a proportional relationship. So we're going to say no. Did she drive at a constant speed? No. Her speed varies throughout the trip, as illustrated by your calculation. All right, let's take a look at this one. Now we're going to get into how do I write an equation if in fact it is proportional. So we've talked about calculating rates of change. I've told you how you identify if something's proportional. That's kind of the main thing. And then if it is proportional, we can come up with an equation because it's just this very specific relationship each time and then the same multiplier or unit rate. Giant thing of cashews, all right? And it says, now 2 pounds of cashews cost $19. And it's kind of deceiving that they say shown, because really, if you take a look at this picture, this says 3 pounds, and if you can read that label, $28.50. And then they give us this information, 8 pounds costs $76. Holy cow. So that first sentence gives us 2 relationships or 2 situations that we've got to calculate. And here's this one for 3 pounds. So pounds, notice I gave you the X there. 2 pounds cost $19. Okay, 2 pounds, $19. I'm just going to put the numbers in here because I got the label here. The picture says 3 pounds cost $28.50. And 8 pounds cost $76. Whoa, what am I doing? This should be 8 pounds on top. Or I shouldn't say pounds on top. Pounds are X, your input. $76. Yikes, you must really like cashews. But that's pretty spendy. All right, write each of these 3 rates as cost per pound. So remember, we're going to put the cost, the dollars on top. That's your dependent variable, Y, over X. $19 for 2 pounds. Simplify to be a unit rate. So divide that out and grab your handy dandy calculator. I'm going to write these as money, by the way. All right, $9.50 over 1. Next one, take $28.50 and divide that by 3. Thank you for the calculator. And ooh la la, what's happening? $9.50 per pound. Per pound. Last one, $76 for $8, or I'm sorry, 8 pounds. Do you need keys? Come on. So when you calculate those two, you end up with the exact same unit rate again, $9.50 over 1 pound. Ta-da! So here's what that tells us, okay? This tells us that I'm getting the same constant rate of change and that this is a proportional relationship. Okay, now, if it's proportional, hot diggity, we can take it one step further. X represented the pounds of cashews. So if you didn't have that in the table, make it sure it's very, very clear to you. Pounds of cashews. The Y value is the cost or the dollars. And when we go to write the equation, we can write it this way. Y equals something times X. And they use that letter K. I didn't choose it. Maybe they're just feeling bad for K because it doesn't get used as often. But K ends up being the constant rate of change. We sometimes call it that constant of proportionality. So what's that magic number? That is $9.50, that unit rate that we see all the time. So the equation is going to look like this. Y equals $9.50 times X. Yay! So no matter what you put in for the pounds, because remember pounds is X, you just have to multiply by $9.50 and boom, there's your price. Take 3, multiply by 950, boom, there's your answer. Take 8, multiply by 950, boom, there's your answer. So if you wanted to extend this and figure out how much would 10 pounds cost at this constant rate, take 10, multiply by 950, $95. You must really like cashews. Holy cow, they're expensive. All right, let's try one. Okay, for a school field trip, there must be one adult to accompany 12 students. Students is your input, the X value. The adults is the Y value, which is your independent variable. Okay, 36 students requires 3 adult chaperones, 60 students, 5 chaperones. So now it's asking you, show the relationship between the number of adults and the number of students and show that it's proportional. Then write the equation. So here we go. Remember, first what you have to do is double check and make sure that your rate of change is constant. Okay, so we're going to have Y over X. Okay, 1 to 12, 3 to 36, 5 to 60. Are these all the same? We just want to verify, okay? Because they're saying show it's proportional, so winky winky probably is. 3 over 30, that is 1/12. 5 60ths is 1/12. Hey, now if you do this on a calculator, because right now this does not look like a unit rate. So let's see what happens here. You're probably really wanting to put this as a decimal. And it does repeat. I don't know if you can see that with the reflection that we get. But as a decimal, this is 0.83 repeating. Kind of convenient. I got that repeating bar in there. Not the 8, just wait, 0.83. Jinkies. Can you tell who hasn't poured her coffee yet? Goodness gracious. There we go. Okay, 0.083. So show that it's proportional. There's my work to show it's proportional. Okay, that unit rate that is consistent is 0.083. Or you could write it as the fraction 1/12. Okay, I'll put that in there. Okay, it's just when we write it as a unit rate, I usually want you to think of it as 1 in the denominator. So it looks kind of weird to leave it as a complex fraction that way. But when you get numbers that aren't exactly delightful, that's how it goes. All right, so then write the equation. So you just have to say Y equals, what is this constant value? 0.083 times X. Or if you're a fraction person, Y equals 1/12 X. Ta-da! There we go. So this is what you're really looking for today, every single time. Let's cruise through this last one. Here's Craig. He's lifeguard. Okay? Lest you think that's an easy job, it's an incredibly stressful job. Trust me. He earns $37 for 4 hours, $64.75 for 7 hours. Okay? Explain how you know whether the relationship between earnings and time is a proportional relationship. Okay, so let's think about this. If I were going to make a table, if I could draw straight, okay, the input is going to be the time because The time is the independent thing, okay? 4 hours gives $37, okay? If you can kind of remember that time almost always is your X value. And then if you're thinking his wages, you're thinking money per hour. And so then it'd help you figure out money is going to end up being my numerator, which is always the Y value. Excuse me. $64.75 for 7 hours. Okay. How do I know that this is going to work? Well, take $37 over 4, take Y over X, okay, and tell me what that equals. Dollars per hour. What's Craig making? 37 divided by 4? $9.25, okay? In this day and age, that, well, maybe if you were a teenager, that wouldn't be quite so bad. $9.25 per 1 hour. All right, let's check and see if it's proportional. 7 hours. Grab your calculator, calculate that one. Boom, ba-doom, dum, da-doom, divided by 7. Oh, hot diggity. It certainly is, again, $9.25 for 1 hour. So, is this proportional? Yes. You can say the unit rates are the same. Unit rates are equal. Ta-da! What is the constant? The constant, or that K value, is $9.25. Well, really just 9 and 25 hundredths. Write the equation. My Y value equals 9.25 times X. Because you're thinking that 9.25, the K value, is what you multiply the input by to get the output. Multiply this by 9.25. Boom! There's your answer. Whew, look at all that. You are being very constant and proportional today. Good luck. Look on Schoology for your assignment, and as always, may the force be with you.